In this drawing on the stomach, we're actually going to do a little bit more drawing than we did in the last drawing. You know, the drawing on the liver was a lot of information and kind of less drawing. We're going to try to make up for that and do some more actual drawing in this lesson. We're going to start by doing some review drawing right here, and we're going to draw the diaphragm and the things going through it again, so you're going to get pretty good at this. So this is the bottom of the diaphragm, and we'll just make it look sort of like that cross section again. Just draw a line parallel to it. Perhaps add some little stripy things to kind of indicate that we've cut the muscle. And then connect this end up to here. I'm going to start here and go down. And then this line over here connects down to here. And we can label that diaphragm. It always looks like diaphragm. And then you can probably guess what these spaces are for right here. We can make a little pipe sticking out, down, and then curve the bottom. Make an oval on top. And this one looks like it's going to be slightly larger. So the first one is going to be our inferior vena cava. I can zoom in a little bit here now. This one, I'm just going to write INF for inferior. Inferior vena cava. And this one is the descending aorta. I'm just going to write DESC for descending. And then aorta. And this is the esophagus. And if you'd like to add some color, you can. You don't have to. We were making vena cava blue because it's returning to the heart. It doesn't have a lot of oxygen. We were making the aorta red because it's got a lot of fresh oxygen coming out of the heart. Make our esophagus look like a tube there. So far, so good. Just review. And then you know it's going to sit under here. In just a minute, we'll draw in the liver. But now we're going to add the stomach in this area. So let's start by continuing this pipe down. We're not going to draw where these things go. The last drawing we were very concerned with all where they go. But we're not really going to do blood supply in this drawing. You know that these come down and they connect up to all the organs. But just to keep this drawing simple, we're going to not show the blood supply. So we want to imagine that this comes down through here like that and connects to this line. And then that comes down to here. And then let's just go ahead and make the outline of the stomach. Finish that. This comes down to here. Nice curve like this. They call this the inner curvature. It's not too curvy. It's kind of like that. And then from here to here, make a slight rise. Just a slight. Although not all drawings show it rising like this, but some really do. And down here like this. So you got kind of a lumpy area right there. And then the bottom come down a little bit. You can kind of draw very, very lightly until you get the curve you like. Make sure it comes down a little bit. And then finish the back. This is called the greater curvature. And then over the top. Like that. And then let's go ahead and finish this little section down here. This is going to be the duodenum. Let's go ahead and put that line in. And then there, like that. See, I'm making kind of a temporary line until I get what I want, and then I'm tracing over it the final line. And then down here, you can see we're going to do a little like cross-section cut. So I made this little like paper thing looking like it's slicing it. So we'll come below that, down, and then just kind of right above that number 1 there. Keep it low. And then pick up this line. Make sure to leave some space in here because we're going to draw something right below the stomach. So don't make this tube too big. Okay, let's go back up here again. And let's put in a few more review items. Now we can see where the liver would go in. Right along here. You don't have to worry about trying to get it just right. It just sits in here somewhere. Remember, it's got this little smaller lobey piece that goes behind here. Like that. And then just kind of come down something like this. So that's the liver. And then over here we've got the spleen. We've drawn the spleen a fair amount, actually. You should definitely know where that thing is by the end of this course. And then let's just add, let's see, the gallbladder and the pancreas. We'll get all the major items in here and then start on detail. Let's put the gallbladder in right here. Remember, you kind of can't see it. It's kind of a dotted line back there. Just peeking out like this. And it goes down. Remember, there's kind of a Y here. There's a branch that goes up like that. And then this duct, this is the bile duct. It goes down behind here, and remember it comes out kind of down here and goes into duodenum or duodenum. You can say either one. I've heard both. Duodenum or duodenum. Okay, so let's label gallbladder. Remember, that stores the bile that the liver makes. And then this would be the bile duct. And this would also be the bile duct down here. And let's label this duodenum. D-U-O, duo. D-E-N-U-M. Denum. Duodenum. And then let's go ahead and put the pancreas behind here. Let me show an illustration demonstrating that it often looks like it sits behind the stomach. Now in some drawings they actually have it coming out like this, some it's mostly hidden. So we're going to make ours kind of showing a little bit but also hidden a little bit. And then we'll see the pancreas more in the next drawing. We'll actually take a look at it and it won't be hidden. For right now, let's see. We're going to make it come down like this, sort of like this shape, like that. I'm going to start down here, and I'm going to make the edges kind of like scalloped like that, so it looks sort of lumpy. The liver looks really smooth, but the pancreas, I think, looks a little more lumpy. Kind of bring it up here like that. And then in here, I'm just going to kind of create some dashed lines. We're actually going to erase a few of these dashed lines in a minute, but for right now, the show goes like that. Something like that. And then I'm going to add a little bit of texture lines like this. Lumpy lines. And then the pancreas also has a duct that comes out. And interestingly enough, in most people, it joins the bile duct down here like this. It actually connects to it so that there's only one hole emptying into duodenum. But in some people, there's an extra one. And here's a diagram showing the variations that they find when surgeons go in to operate. They find that some people are like this, with a pancreatic duct like this joining, and an extra piece that looks like a Y, so that they actually have two holes in the duodenum. And there's another one with two holes. Some people, though, only have this one that joins up. Some people have two holes, but these aren't connected. And some people have an extra little connection that goes like this, kind of around like that. So these are all variations on normal. So in our drawing, I don't know, maybe let's put in a little extra one right here, just so we know that this is possible. We can add a little extra one. Let's say this person has this arrangement where they've got one joining here, and then these would join up. We're not going to draw inside the pancreas. But just so we know that sometimes there can be two openings into the duodenum. And then let's label this pancreas right about here. We're going to have some lines crossing up here, so label it right about here. Pancreas. So there's the basic anatomy. You can pause and look at that if you need more time to sketch in. But I'm going to go ahead and talk about some more inside details here. We're going to start right here where the esophagus comes down and joins the stomach. And I'm going to zoom in so you can see what I'm going to draw here. There is a ring of muscle, a pretty thick ring of muscle, right here like this. So you see there's a hole, although, you know, it would be closed tight most of the time. There's a thick ring of muscle like this that squeezes and keeps this closed. And then food can pass in, it can open, and food can come in. And this is called a sphincter muscle. Sphincter is a muscle that works backwards from most muscles. Usually when we want to use a muscle, we contract it. So in its kind of normal state, it's relaxed, and then we contract it, and then it relaxes again. In a sphincter, it's contracted all the time. And to use the muscle, we relax it. Now, often we don't think about relaxing these. You don't have to think about relaxing the sphincter. There's other sphincters that we can consciously relax, like the one at the end of our digestive system. When the feces are ready to come out and you need to use the bathroom, we can sit on the toilet and we can consciously relax that sphincter and let the feces go out. But here, this is under involuntary control. You don't ever have to think about it. So this is called the esophageal sphincter. And I'm going to use some of this liver space here. Esophageal, G-E-A-L. Sphincter. Sphincter. There's a C in there. It's kind of strange because we got two words right together that both have PH in them. It's kind of unusual. Muscle. Esophageal sphincter. And then let's make a little piece of food coming down. There's actually a word for this. You know, when you bite, chew, and swallow, the food comes down in little bits, right? A mouthful. When it gets down here, it's called a bolus. B-O-L-U-S. A bolus, I'll put, of food. So make sure we know what that is. So the bolus comes down and then it's pushed through here and it plops into the stomach. And we can even make it coming down into here. Plop. I'm going to make a sort of a water line. There's a point to it. Not that the stomach is always filled with water, but it is. This is filled with very acidic fluid. Stomach juices are very, very acidic. And the reason I really wanted to add this line is to emphasize that there's a top part that often remains empty. It's just full of air when you're standing or sitting. Now when you lie down, obviously food's going to slosh up there. But a lot of the time this top area is kind of empty, and this area is called the fundus. F-U-N-D-U-S. And then this area is just called the body of the stomach. And then there's a name for the region down here, and we're going to cut some holes and look inside this. I'm going to come back to the body of the stomach. We're going to take a closer look at that. But once it goes through here, it'll come down here into this region called the pyloric region. But first we're going to draw another ring of muscle right here. This one is a little bit shorter like that. And it's named after this region. This is the pyloric area, or the pylorus. P-Y-L-O-R-U-S. We have the fundus at the top and the pylorus at the bottom. And so this is called the pyloric sphincter. So let's see, I guess I'm going to write it over here. I might add a note here, so I'm going to write pyloric sphincter right here. So this region kind of here is the pylorus. One of the things that makes it a distinct region is that the muscles in this area are stronger even than the muscles in the stomach. And the muscles in the stomach are pretty strong. But this has stronger muscles, so it can really push the food through the sphincter muscle. So I'm just going to put a little note here. Has stronger muscles. At least that's what I read. So hopefully my sources are right. I read that it has really strong muscles. So this will open a little bit, but then this really has to push it through. Once it gets through here, we'll make a big yucky sludgy mush going through like that. It's not called a bolus anymore. And it's kind of mushy. It's not really in a ball. It's called chyme. C-H-Y-M-E. And it has to be pretty mushy because it's going to head down into the intestines. And those intestines bend and twist. And you don't want big chunks of stuff getting stuck. And the way that it's going to get pushed along is a muscular action called peristalsis. So let's write peristalsis, P-E-R-I, peri, stall, S-T-A-L, and then S-I-S. Peristalsis moves the chyme along. And we're going to look more at the muscles that do this in just a minute. But there's a good word to know. Actually, I put some of these words in a word list up here. can actually add a few of these words to know. The first one, a wad of food traveling down the esophagus, is bolus, B-O-L-U-S. And that mushy stuff goes into the intestines is chyme, C-H-Y-M-E. And here we have the next one is the muscular action of the digestive tract to push food along, and we just said that is peristalsis. So we've got those three filled in. So now let's cut some holes in the stomach and look inside. The first hole we're going to cut is going to be right about here, a rectangle. Now it's going to go over some of that dotted line pancreas. I may have to just erase some of that. Something like this, right here. And then we're going to make a flap. Oh, just for fun here. Make two curves going like this. Connect them. And then make that one look like it has a little bit of thickness. And then if you shade a little here, here, it's actually going to look like a flap. I'm not trying to be gross cutting flaps in your stomach. It's just a diagram. This is going to be a shallow flap. We're just going to take off just the outer layer here. In fact, this is probably a little bit thick. It looks kind of nice though like that, but very, very thin. And then if we draw a line here like this, you see we can make it look like it's a little kind of boxy window. See if I can go a little bit closer here. Okay. And we're going to divide this into thirds. We're going to see 3 layers. So as we go down, the first layer we come to is going to be a layer of muscles going like this, long ways up and down. So because they're long, we call them longitudinal. So we're going to see them in like this. And then if we peel those away, so imagine that's a layer, and we peel that back, the next layer is going to be muscles that go around the diameter like this in a circle, so we call them circular. So they would kind of look like this, going around. And then if we peeled that layer, we would find a third layer under that that is going kind of diagonal. So it would be kind of halfway between this and this. So if we rotate it like that, it would actually kind of be going straight up and down like that. All right, so let's label these using this space over here. Leave a space here, don't write anything under here. Come down about here, and we're going to write longitudinal muscles, circular muscles, and oblique, O-B-L-I-Q-U-E. And then point to each one. Now you're going to find 2 of these muscle layers in the entire digestive tract, and that would be the longitudinal and the circular. So for example, up here in the esophagus, you would have muscles lining the esophagus. You'd have longitudinal and circular, and that's what pushes the bolus down. you're going to have, see, let's put a note right under here. The esophagus has longitudinal and circular muscles that do peristalsis. And you're going to find these two layers of muscle also all through the duodenum and into the small intestine and even in the large intestine. The stomach is the only place where you find this oblique layer, because the stomach has to do more complicated motion. Here you just need a squeezing motion. Squeeze, squeeze, squeeze. You just need to move the food along. Just kind of pinch, push, and move it. But in the stomach, you have a more complicated kind of, go out a little bit so you can see my hand, kind of a kneading motion in the stomach. It's a little more complicated. So you need this oblique layer. So now let's cut another hole right here. We're going to make a nice square-ish hole. We won't put a flap on this one. We'll just cut a hole. Look all the way in. And if you draw a line across here like this, and then a little line into the corner, and a line down, it kind of looks like you've cut into it there. And if you want to make it look like it's a hole, we're going to shade a little bit. Make it darkest over here on this side and in the corners, and then get a little bit lighter. Hopefully yours is looking like a hole, like that. And then we're going to see the back wall, aren't we? If we're looking into this hole, we're going to see the back wall of the stomach. And what we would see is something like this. Some folds and wrinkles. Oh, and here's the layers, right? There's the 3 muscle layers. And then, well, our hole looks a little more simple, but that's what we're trying to draw, a cutaway. And then you're going to see these wrinkles and folds. And we can do that pretty easily by just making some dark lines. Maybe you might want to make one going off like that. Doesn't matter, whatever shape your lines are is fine. And then let's write a note right here. We'll connect it. We're going to say deep folds in the walls of the stomach. Deep folds in walls of stomach. Allow it to expand. And I'm going to add a note in parentheses. Expansion causes the muscles to begin contracting. So there's a little mechanism there where the expansion is part of what triggers the muscles to start doing their job. All right, so let's point to that. So now let's take a close-up view of this wall that we've cut through. We're going to do that down here. Mine says cross-section of stomach lining, but I think I might change it. Yours will probably say a cross-section of stomach wall. And I'm going to take a almost microscopic view. Speaking of microscopic views, here is one. Ours, of course, is going to be a diagram. Look a lot more simple than this. We're going to have this top layer of cells. You can hardly see here, but these are going to go up and down, little villi, and then there's going to be a layer of connective tissue, and then underneath here we're going to see the muscular layers. So that's what it actually looks like, and then let's simplify it. Come about halfway down or so, and we're going to make some big tall things called villi. And I'm going to fit about 4 on mine, I think, something like that. You could put 3 on yours if you wanted to. They're actually packed together really tightly. Like in that picture, you couldn't even really see them. But in ours, we're going to keep them separate. Okay, and these are villi, V-I-L-L-I, 1 villus, 2 villi. Now, don't get confused with microvilli. We're going to see in the intestines that the villi have villi. So the big ones are villi, and the little microscopic ones are microvilli. So these are regular villi. And of course, their purpose is to increase the surface area. Because if you straighten this line out, it would be very, very long. So then you need to make a line under that, because this is actually going to be a line of cells. This is our quick and dirty way of drawing cells. We're just going to go like that and then put a bunch of straight lines instead of trying to draw each cell individually. And then individual cells. So this whole region with the villi is called the mucosa. We can write that in number 1 here. Mucosa. So we're probably going to see some mucus cells in here, you might guess. And then it goes down to about here, and then the layer underneath it here is going to be the submucosa. So we could go ahead and write down in here submucosa. And of course sub just means under. So this section, if we make a little parenthesis kind of in here, this will be the submucosa. And this is basically loose connective tissue where we're going to see some blood vessels running through. But let's look at the cells here of the mucosa. The top part of these villi have something called pit cells, and I think I'm going to choose a yellow. I'm just going to kind of indicate that the top part of the villi are very different from the bottom. So this is our first kind of cell, and it's going to be A in our list over there. Right here, A is pit cells, P-I-T. And so I'm going to put a little yellow right there. These are, you can label it here or not, either way, pit cells. Now, they're called pit cells, like where's the pit, right? Well, this is the pit right here. This part right here is called the gastric pit. Of course, anytime you see gastric or gastro, that G-A-S-T-R, that means something to do with the stomach. So there's the gastric pit, and then the space below here is called the gastric gland. So indicate somehow, I'm going to put a box around mine here, from this part down, right here, this section is called a gland. And I was really confused at first. I'm like, well, I thought it was the pit. But they just divide the space in half. The bottom is the gastric gland. So when they kept saying about digestive glands, I'm like, where are they? I don't see anything. I see villi. Well, the gland is just that deep space between the villi. And so all the cells that make the gland are these things right here. So there's a type of cell that sits right here on the border. It's like a wall between this part and this part. I'm going to make mine green. I don't know why. You can choose a different color. Doesn't matter as long as you indicate it over here. This would be B. And since these kind of form a wall, they use the word parietal. Now we saw this in the brain drawing. We had the parietal lobe. Parietal, though, doesn't mean anything with the brain. Parietal just means wall. So P-A-R-I-E-T-A-L. Parietal cells make hydrochloric acid. Alright, so the pit cells on top are the things that make mucus. And it is to protect against the substance that these parietal cells are making. I mean, this thing's pumping out acid, and if these guys didn't have mucus to protect, they'd get destroyed. So you can even put it, just makes a whole layer of mucus on top here. Covered with mucus. There's thick mucus lining over the whole stomach. I don't know if you have a different, maybe a different color, yellow even, or something. So this is mucus. So it's a good thing they're protected and ready when these cells start cranking out their acid. And the reason they're producing acid is because of another product that one of these cells down here is making. There's a digestive enzyme that needs acid to be activated. So let's draw those in. Number C, that'll be C here. They're called chief cells, C-H-I-E-F. Now I think I might leave the chief cells white. I'm just going to put a white box since there's more chief cells than anything else. So if I can get a tiny bit closer there. I'm just going to leave them white, and then I'll make these two a color. So the chief cells make Pepsinogen and something called IF factor that protects vitamin B12 from stomach acid. So everything coming in the stomach is going to get bathed in acid, and the vitamin B12 molecule will be destroyed. So cleverly enough, these chief cells make a little protective safety device that goes and attaches to B12 and protects it as it goes through the stomach. Now Pepsinogen might remind you a little bit of the word fibrinogen. And remember, gen, when you see G-E-N on the back of a word, that means to make or to create. So Pepsinogen makes pepsin. Fibrinogen makes fibrin. So what is pepsin? Pepsin is the enzyme that digests proteins. And we could just put a note here. Just use this space. Pepsin digests protein. But again, we don't want a harmful molecule getting out. Pepsin will digest any protein. It would even digest the protein in these cells on its way out. So you don't want these cells to be destroyed by pepsin. So it goes out as pepsinogen, harmless enough, and it only gets activated as it picks up this acid. So when it gets out in the stomach, the acid turns it into pepsin. So let's make the so let's choose 2 colors for these remaining ones. I don't know how about, I'm going to maybe whatever color, make one purple or pink or blue or whatever you want to. Actually, don't use red and blue because we use red and blue for the blood vessels. So a couple of these are going to be a type of cell called G cells, like the letter G. And G stands for gastrin, right here. And that is a hormone that will stimulate the parietal cells, and I think a couple other too. It helps get digestion going. So those are the G cells making gastrin, and then we have a couple other cells that are making some other little hormones. And at this point, we're getting into detail that, you know what, at your level, you don't really need to know all this. So I'm just going to write this here. It'll be here. You can come back to it, but we're not going to go into what these hormones are or anything. But they're called Entero endocrine cells. E-N-T-E-R-O, and like the word enter with O. Entero endocrine. I didn't leave the space for cells here. Cells. Okay, let's give these guys some blood supply. We just mentioned that we needed the blood in here to transport hormones around. So we're going to go like this and up. This will be our little arteriole. Like that. We did this in, I think, was it the skin drawing maybe? Or we drew this. And then we want to pick up where we left off, right? Because the capillaries don't just dead end except for like one place in the body. But here they go up and over, and then they turn into a venule, and then go down, and then we'll draw another blue line down here, the connecting venule. So every one of these will go up and over, down, kind of goes behind that picture. And this space right here, as we've already indicated, where these venules lie, is the submucosa. And this would be, remember the loose connective tissue? We had collagen running everywhere, and there's immune cells. You know, there'd be immune cells lurking in here, which you rarely see put into drawings, but there would be immune cells in there, and there would be collagen. And what is the collagen connecting to? The collagen will connect to the next layer, which is the muscle layer. And that would be number 3. It's called the Muscularis. Sounds like an official title. It just means muscles. And so we already know A, B, and C. We can fill these in. We know it's the longitudinal, the circular, and the oblique. So draw a little thin line at the bottom here. That'll be the bottom layer. And then this space in here you can divide into 3. And And let's see, I'm going to make longitudinal because it's a cross section. It'll kind of look like that. It's circular. It's kind of opposite because you think long. You think this one would be the longitudinal, but if you're seeing a cross section, oftentimes it's the circular ones actually that look long. Alright, and this one, I'm not sure how to draw it. I'm just going to draw a diagonal to remind me. I'm not sure how it would look in cross section, but that's the oblique. Alright, so it's longitudinal, circular. The bottom, I think I'll use orange for this. We have a layer that we've actually already discussed back in the lung lesson. We met this. This is called the Serosa. S-E-R-O-S-A. The serosa is a layer of epithelial cells. So these would all be epithelial. And then there's a little bit of connective tissue, collagen, to connect it to this layer. Basically, these are epithelial cells that secrete serous fluid for lubrication. So we have the same situation in the abdominal cavity as we had in the thoracic cavity, and that is we want the organs to slide a little bit. We don't want friction because we're bending and moving and stretching all day. We're moving, and we don't want our organs rubbing. So these guys are the ones that secrete a little bit of fluid to keep everything nice and slippery inside. So now let's go over and do our last cross section over here. This is going to be a cross section of the duodenum. And I've given you a starter circle, but we're going to kind of draw the serosa outside of this. So you could actually go ahead and do that. This layer that we just drew, the serosa, we're going to have this around the outside of the duodenum also. And then I can just use these. Actually, over here I should have pointed maybe to this also. The bottom here, this is serosa. Alright, so let's jump to the inside now. The very inside, you might think it's going to look something like this. Right? It's got a hole in the middle. It's like a pipe. But actually, this line is wiggly. And the reason is because it's adding surface area. So if I straightened this line out, it would be a lot larger than the one I just drew that was just straight. The inside is called the lumen, L-U-M-E-N. And the word lumen you see a lot in biology. It's always used to refer to that inside space, inside a tube, like the inside of a worm would be the lumen. So this is not unique to the digestive system or to the human body. It's just a common word. It just means open, empty space inside. So the lumen is created by this layer. Now we're going to use these, so which layer do you think might come next? If this is the outside and we're working in, the inside would be the mucosa. Right? So let's draw these. So we can point to this, number one. And we could even make it same color. If we want to, we can colorize this one. We didn't use much color in our major anatomy drawing, but we can add a little bit to these diagrams. Alright, so next we have layer 2, the submucosa. For this kind of, don't go in a lot, it's more like something like that. It might go in a little bit, but it's approximately circular. So the space in here, let's see, I didn't actually color that in the other drawing, so I don't know what color you can make it. Maybe I'll use pink for this. I don't know. Use something light. Again, the submucosa would be that areolar or areolar loose connective tissue. It'll have collagen and elastin going everywhere. Immune cells. Remember that from our tissue drawings. And that would be the submucosa right here. And then we have the muscular layer. Now we don't have the oblique in the duodenum, so we're just going to divide this in half. And we'll put the longitudinal on the outside, like that, and circular on the inside. Actually, this cross-section reminds me a lot of a worm. If you've ever done a drawing of worm anatomy, basically a worm has a ring of circular muscle and a layer of longitudinal muscle. And that's how it makes its motion. You know, you've seen worms crawl around. The worm is just coordinating its circular and longitudinal muscles. So your intestine is a lot like a worm. And so let's see, we've got the longitudinal and we've got the circular. Now we're going to go back up to the top and we're going to add some nerves. I'm going to use purple. I don't know why, but I always seem to use purple for this. And we're going to add, instead of the blood supply, we're going to add the nerve supply. And this is a very important word called the vagus nerve. I'll just show you a Gray's Anatomy picture got off of Wikipedia. It shows how the vagus nerve comes down from the brainstem. It goes down through your neck, along through here, and it travels along next to the esophagus. And then down through the diaphragm, there's the diaphragm. And then down, and this is the stomach, and it goes into the stomach. The vagus nerve also splits off and goes into the liver and the spleen and the intestines and the pancreas and all the other things too. So we're going to just draw it right along the edge here, and it sneaks through this hole. You know, there's only 3 holes, so everything has to go through. So you're like, well, we've used them up. The Vena Cava, descending aorta, the esophagus, where does the vagus nerve go through? Well, it just runs right along the side of the esophagus and just slips right through there. So we're going to draw a nerve. Now they call it the vagus nerve. They kind of speak of it in the singular as if it's one nerve, but it actually has a left and right branch like this. Comes down here, along the outside here. Draw it here. Now we're not going to worry about being super accurate about where the left and right branch go and what they innervate. That's the word for when nerves go into something. They innervate it. They innervate it. So we're just going to go like this a little bit. We don't want to interfere with what we have drawn here. We don't want to make the drawing look too complicated, but let's go along here and just indicate that we know that everything's controlled by nerves. Because when you want a muscle to contract, there's only one way to do that, and that is to have a neuron tell it to contract. And we saw that back in the nervous tissue. That's the job of a motor neuron. They have to give the signal. There's no other way to get it to contract but to have a neuron tell it to. So let's see, it'll go up here a little bit, it'll go down there. And then let's bring, I don't know if this is anatomically correct, but bring one down like this, just so we know in the diagram that the vagus nerve controls pretty much all the organs. It doesn't go down to the bladder. I don't think it goes down that far, but it does go down into the intestines. And it would go into the pancreas. You know, what does the pancreas need nerves for? Well, if you have pain, you know, you need to know about it. So the vagus nerve would have both afferent and efferent nerves in it. So it would pick up signals, like pain signals, from here, and it would also send out signals that are needed. Okay, we don't have to go too much detail about putting it all over, just enough to know it's there. And let's label it. I could label it here, maybe. Vagus, V-A-G-U-S. Vagus nerve, and maybe I can label it here, at the top maybe. You can label it anywhere you want to. This is one of the major nerves of the body, so it's good to know it's there. And then we just need to fill in 2 more words and we'll be done. Our words to know, I thought we really should mention these 2 words. And one of them is the correct name for a sore in the lining of the stomach. We talked about how the mucus protects the stomach. Well, what happens if there isn't enough mucus there? Does the stomach then get damaged? Yes, it does. And we call that an ulcer. U-L-C-E-R. Now, a lot of times when an ulcer forms, the reason it starts is because of bacteria. They used to think that ulcers happen because you were nervous, you drank too much coffee, and all those things don't really help your stomach. It's often got a bacterial cause, so now they treat ulcers with antibiotics. But at any rate, that's what you call a place where the lining wears thin and there's not enough mucus. And this is something to be aware of when you take medicines such as ibuprofen, NSAIDs they call them, aspirin and ibuprofen. One of the side effects of that type of medicine is that it prevents those pit cells from functioning. And so you get reduced mucus production. So that's why they're so concerned about these NSAIDs being hard on your stomach, because they interfere with the action of those pit cells. Alright, the last one is a kind of cool word that starts with the letter Z. I kind of like this word. Z-Y-M-O-G-E-N. Zymogen. So you actually might be able to guess what a zymogen is. You have gen, which means to make or create, and you have zyme. And you're probably thinking that looks a lot like enzyme, and you're right. So this is something that makes an enzyme. So, and we call it a precursor sometimes. And so the examples are, of course, fibrinogen and pepsinogen, which we've already talked about. And that's the form that many enzymes are actually made in, is a zymogen. And that's a relatively new word in the field of biology, but it's very useful, and you'll probably see it popping up again somewhere before the end of the course.